Let's go over some of the solutions to some of the test C questions. So in 7 through 10, you're asked to find the value of the trig function. And basically what you do on these problems is you just look at the question. In number 7, we are asked to find the cotangent of theta. And so theta is here, and I identify that, and then I label these sides. So the 12 is across from theta, so that is the opposite side. And the 20 is across from the 90-degree angle, so that's the hypotenuse, and the 16 is the adjacent. And then what we're going to do is we're going to build a fraction using our trig ratios. So remember, cotangent of theta is the adjacent over the opposite. Cotangent is the reciprocal of tangent. So if tangent is opposite over adjacent, cotangent is adjacent over opposite. That means that I need to put the 16 over the 12. So for us, and this is number 7, that'd be 16 over 12. That reduces to 4 over 3. And so the answer for this problem is letter A. And I would be writing A in the box and bubbling in A on my sheet. For number 8, we're asked to find the tangent of theta. So again, I'm going to label these parts. Theta is here. 4 square root of 10 is the opposite. 6 is the adjacent. And 14 is the hypotenuse. For tangent theta, I need the opposite over adjacent. So my fraction is going to be 4 square root of 10, which is opposite, over 6. And then I just need to reduce this. 4 and 6 reduce to 2, 3, 2/3. So that's 2 square root of 10 over 3 for number 8. And luckily, here it is, letter B. Number 9, we're asked for tangent again. This is not very exciting. So we're going to label. And let's see what we can come up with here. I'm looking at theta. So opposite is 9. Adjacent is 12. And 15 is hypotenuse. For tangent theta, again, we need the opposite. Oops, I kind of spelled that wrong. We need the opposite over the adjacent. And so that is 9 over 12. And 9/12 reduced to 3/4. So I'm looking for letter B on this one. And finally, in number 10, we're asked to find cosecant of theta. And the cosecant ratio is the hypotenuse over opposite. And so let's label these. Opposite is 2. Hypotenuse is 2 square root of 10. And we don't need the adjacent, but the adjacent's 6. So remember that for cosecant theta, we need hypotenuse over opposite. The hypotenuse is 2 square root of 10. And the opposite is 2. And these 2's cancel. And this answers the square root of 10, which looks like it's letter C. Excellent work here. So that is going to be my choice for this problem. So for each of these 4 problems, you really just need to have memorized your ratios. And we have these shortcuts, SOHCAHTOA and SHOCHOCOW, that help us remember that. And as you get set up, label hypotenuse, opposite, and adjacent on each triangle, and then pay attention to which ratio you're doing and make the fraction. We're just making fractions on these 4 problems. Okay, let's take a look at a couple other problems from the test. When you get to 11 and 12, you're asked to find the measurement of the indicated piece. So in this case, I'm trying to find angle C, right here on number 11. Now, the first thing I notice about this problem is these are not right triangles. The only thing I know for sure is that angle A is 62 degrees. the side opposite of A is 28, and the side opposite of C is 25. This is a perfect setup for the law of sines. So I'm trying to solve for angle C, so I'm going to write down sine of C. That goes over side C, which is 25. And that's going to equal sine of A, which is 62, over 28. And I'm just going to label this as number 11 here because I'll do number 12 in a second. Okay, to solve this problem, we multiply both sides by 25, right, to cancel out this denominator. And then to get the sine of C, which is not the answer, I have to compute this on my calculator. And that's what I'm going to do right now. Type in the sine of 62, make sure you're in degree mode. Sine of 62 times 25 divided by 28, excuse me. And that comes out to be approximately 0.7883. And I go ahead and write that down. To solve for C, which is the thing we're trying to finish, we have to do the inverse sine on this number, right? We're trying to undo the sine function. And we're doing the inverse operation here, so this is going to be the inverse sine of 7.883. On your calculator, your last answer is hopefully saved, and so you can just do inverse sine on your last answer. And I end up with 52.03, and then I'm going to look at my choices and choose the one that's closest to 52.03. And that is letter D right here. So I'm choosing D on this problem, 52. Number 12, we're going to attack in the same way. So I'm looking at this problem, and I notice that I'm trying to find angle B, which is this guy right here. So on my picture, I make sure I have the correct information. I have B, I have side B here. Letter C, angle C is 125, and then side C is 45. So again, we'll run through the law of sines. Let's see, so I'm going to do sine of B, that's the angle that I don't know, so I got to use the letter, over side B, which is 33, equals the sine of C, and C is 125, over 45. We solve this one the same way we solved the last one. I'm going to multiply both sides by 33. And remember, these cancel out. And I end up with the sine of B equals, and to figure out what the sine of B is, I'm going to multiply this whole thing on my calculator. Sine 125 degrees times 33 divided by 45, and I get approximately 0.6007. To solve for angle B, which is what we are asked to solve for, I'm going to have to do the inverse sine to undo that sine, right? And so I use the inverse sine of that value, 0.6007. And actually I have it saved in my calculator as I mentioned, so I'm just going to do inverse sine, inverse answer, and I get 36.92 approximately. And notice B is 36.9, so I'm going to choose that for my choice here. So for these problems, you're using the law of sines. And in both of these, we happen to be looking for angles. You know that sometimes we look for sides when we do these problems. But if you're looking for angles, make sure you use the inverse trig function right at the end to figure out what the angle measure is that you're looking for. Okay, let's take a look at one more little set of problems here. So in this section here with number 18 and 19, we're trying to find the missing side. And the way you decide what you're looking for is you look at the picture here. So I'm looking for letter X on number 19 here. I'm going to work on number 19. You have a couple of choices for solving these problems. You can either use our trig ratios, like our SOHCAHTOA, to solve for the missing side, or you could set up a law of sines situation. I prefer to just set up the SOHCAHTOA, it's usually less calculations on your calculator to do that, and less algebra. But to do that, you have to remember what your ratios are. So I'm focusing on angle 31 because that's the given angle. Side X is opposite angle 31, and 16 is adjacent. Opposite over adjacent is a tangent scenario. So when I write out this equation, the setup is going to be the tangent of my angle, which is 31 degrees, equals x over 16. Now, tangent of 31, that's not on the unit circle, so I need to compute that using my calculator. And so I just go to tangent, hit 31, and it gives me 0.6009 when I round it off. And we've been writing those to 4 decimal places. So the equation that I need to solve is 0.6009 equals x over 16. And then the simple way to solve this thing is multiply both sides by 16. So when you do 16 times 0.6009, just multiply by 16 on here, and that comes out to be 9.614. I'm going to call it 9.6, and then I'm going to look on my choices here, and sure enough, letter D is 9.6. So I prefer to use the regular trig ratios to solve these problems. If you wanted to set it up with law of sines, you could, but you'd have more calculations to do. Okay, that was just a brief set of solutions for some of the problems that we had on our test. I can do more in a different video if anybody needs those. Keep up the good work, and I'll talk to you soon.